Again, so today we're going to be building polynomials with conjugates roots. Last Thursday, we create and wrote the polynomial functions or equations based on the roots that are real, right? And based on the leading coefficient, based on the description, the graph of the polynomial. But again, there are some roots that are not real. They're imaginary and complex roots. So how do we create or write our equation based on these roots, okay? So this is going to be our goal today, right? So the first part here, we're going to review how to find the zeros or roots of a polynomial p of x, right? Because if you are going to find these are just the values when you set p of x, the polynomial, equals 0, right? Now, graphically, the real zeros are just your x-intercepts of the polynomial function. But again, not all roots or zeros are real. Again, some can be complex or imaginary, and some can be irrational, okay? So just like what you had in your warm-up, if we're going to find the zeros of x squared minus 5 equals 0, we cannot factor x squared minus 5 because 5 is not a perfect square. So we cannot do difference of two squares, right? So what we can do is just do the square root method. So to do the square root method, we just have to add 5 on both sides and take the square root. That's it. So you do x squared minus 5 equals 0, plus 5, and then x squared equals positive 5. And again, you want to solve for x, right? So you want to isolate the variable x by taking the square root on both sides, right? But if you want to take the square root of this number 5, make sure you have to take the plus and minus, right? The positive and negative version. Again, this is quadratic polynomial, and so you're expected to have how many? 2. Okay, 2 roots. So x can be square root of 5, and x equals negative square root of 5. Now, I'm just going to write the word, they are conjugates, okay? Because we're going to use the term conjugates later. So these are irrational conjugates. Right? Irrational conjugates. And again, conjugates comes in pair. Okay? So that means if you have the square root of 5, then it comes in pair. So you should have the negative version of that, negative square root of 5. And then let's try x squared plus 16 equals 0. Now, can we factor this using difference of two squares? No, because yes, we know x squared and 16 are perfect squares, but the operation is addition. So you cannot do the difference of two squares method. So we can also still do this method here, which is the square root method. Okay? But again, if you subtract 16, the right side will become negative, right? So x squared plus 16 equals 0. You subtract by 16. And so this is going to be x squared equals negative 16.
Is this imaginary 4?
Yes. So if you have a square root of a negative number, remember, in your irrational roots or complex roots or complex numbers, I don't know if that was math too. If you take a square root of a negative number, that's going to be your imaginary, right? So yes, plus and minus the square root of negative 16. Yes, but then I can break it down so you have like plus minus square root of 16 times square root of negative 1. Right? Because 16 times negative 1 is negative 16. I did that because every time you have a square root of a negative 1, that's your imaginary, right? Square root of a negative 1 is I. So therefore, we know square root of 16 is 4. So I can have plus minus 4. Square root of negative 1 is I. So it's going to be plus minus 4i. Okay, so again, the roots are 4i, positive 4i, and negative 4i.
What's the difference between like the plus and the minus and then the imaginary?
The plus and minus is That is because we are going to find two roots, right? So it's going to be either positive version and the negative version of the number. But then the square root of -1, right, is your imaginary. The value of that is square root of -1. Every time you can see an imaginary number. Okay? The plus minus is just the sign of the number. Okay? Yes?
So if you were to just write it as plus or minus -16i instead of doing it times -1, times the
Negative, that's fine.
is that
Yeah, that's fine. Yeah, because you know that if you have a negative, square root of a negative is I. So you can also do x equals plus minus square root of 16i. So make sure you put the I outside the square root. Because if you put it inside, then it's going to be redundant, right? Because the square root of -1 is already I. So you have to put the I outside. Yeah? You can do plus and minus. If you do both signs, plus minus, I will consider that as correct. Yes. Plus minus, that means there are two roots there. Plus minus 4i. I'm just showing that we have two different values, right? Positive and negative. And these are your complex conjugates. Okay, the first part is your irrational conjugates. These are your complex conjugates. I'm just defining the terms and the values, right? Okay, again, conjugates comes in pair. It can happen with irrational conjugates and complex conjugates. Okay? Now, what about this? If you have x squared minus 4x plus 5 equals 0, how do you find the roots? Because we're going to find the zeros of this polynomial. X plus 5. So you mean we can factor this by 5 and? -5 and 1. That would be -5. So can we factor this? That's the question. No. Okay? So therefore, if we cannot factor a polynomial, that means the roots are not real. And so every time we can see a polynomial that is not factorable, then we have to use other methods. Right? You can do either completing the square or the quadratic formula. Okay? Can you still remember quadratic formula? What's the formula for quadratic? Let's try to use this method instead, okay? But again, in your quiz, the last question, that was factorable. So you don't have to do quadratic formula in there. But this one is not, okay? So what is the formula? X equals -b, yeah, plus minus the square root of b squared minus 4ac all over twice a. Okay, so here we're going to identify our a, b, and c so that we can plug it into the formula and solve for the zeros, right? Again, on the test, some of the polynomials are not factorable, so we have to know how to use other methods, okay? So what is your a value here? 1. These are just the coefficient, right? A, B, and C are just coefficients. C is your constant. What is your B? -4. And what is your C? 5. So we're going to plug in all these values to the formula and solve for our zeros. Again, we should have 2 zeros here. That's why it's plus and minus. Okay? So let's do x equals negative of -4 because your B is -4. And we have a negative sign there, so it's going to be +4. Plus minus square root of, we'll just do and simplify this. What is -4 squared? Because that's b squared, so 16 minus 4 times a, which is 1, times c, which is 5. So minus 20, okay? And then all over 2 times 1 is just 2, okay? And we just have to simplify this further. So we got 4 plus minus. 16 minus 20 is -4. and then over 2. Okay? Now remember, we have a negative number in your under your square root or inside your square root. That means we have an I here, right? Imaginary. So I can write 4 plus minus. What is square root of negative 4 in simplified form? 2i. Okay? It's because square root of 4 is 2. And because of the negative, we got to put I beside the 2, right? So 2i over 2. And so we can simplify because we can divide 4 and 2 by 2. So that's going to be 4 divided by 2. That's 2. Then plus minus 2i divided by 2 is just I, or 1i. Okay? Therefore, your answers are, you can do 2, and then if we take the plus, positive version, so 2 plus I, and then the second one is 2 minus I. Okay? If you put plus and minus, that's fine. But I'm just showing you there are 2 roots, 2 plus I and 2 minus I. Okay? Any question? Again, these are your imaginary or say complex conjugates. Any question? Okay. That's not the goal today in our class, okay? I'm just showing you that, again, we can have imaginary roots. The goal today is, given these roots, how do we create our equation? So we're working backwards, okay? We're given this, and we're going to write our equation, all right? Okay, so we have, again, irrational and complex roots always come in conjugate pairs. All right, so let's complete the table, because we already know what we mean by conjugate, right? Right here. Okay, so if we have, these are the known roots here. Square root of 7, what is the conjugate of this root? It's just a negative square root of 7. Okay? So that means if you're asked to find the conjugate of the given root, it's just the opposite sign of the given root, right? All right, so what is the, if known root is negative square root of 3, what is the conjugate? It's the positive square root of 3. Okay? Again, the first two are your irrational roots. And then we're going to do the conjugates of these imaginary roots, the last 4. Okay? So what is the conjugate of 3i? Negative 3i. What is the conjugate of negative 2i? Okay, plus 2i or positive 2i. What is the conjugate of 1 plus 5i? 1 minus. And then the last one, what is the conjugate of 3i minus 7? 3i plus 7. Okay, and again, the last 4 are your complex or imaginary roots. Okay. All right, any question with these? Okay, so now we just have 3 examples, and we're going to write our equation in standard form. Okay, so that means once we have the intercept form, just simplify to come up with a standard form. All right, so again, any root with a square root or I will have a conjugate pair, right? So what is the degree, class, if it's a cubic polynomial? 3. Okay, so it expected that we should have 3 roots and 3 factors, right? So let's write all the roots here and then convert it to the factored form. So what is the first root? X equals 2. And what's the second one? X equals 3i. Now, since we have a 3i, that is an imaginary. So this one comes with its pair, right? To complete 3. Because there should be 3 roots and 3 factors. So what is the conjugate pair of 3i? Negative 3i. Okay? So now we're just going to write these as a factored form. So x equals 2, what is the factored form? X minus 2. X equals 3i, what's the factored form? X minus 3i. And then x equals negative 3i. Of course, x plus 3i.
How come there's no x equals -2?
Because again, 2 is real. You can only have a conjugate pair if it is what? This and this. All right. Any other questions? All right. So again, we should have a total of 3. If we're gonna find a pair of 2, it's gonna be 4, and we cannot have 4 because this is just cubic. All right. So how do we write this now in intercept form? Y equals 1/2. So we're gonna start with the leading coefficient, right? So 1/2, and then times all these factors. So times x minus 2, x minus 3i, and then x plus 3i. Okay, but again, this one is, what form is this? This is your intercept form, okay? Or this is your factored form. But what is asked in the problem is to write it in the standard. Okay, so we're working backwards. We have this, and we're going to create our equation, okay? So what we can do first is we can multiply this last 2, right? And then once we have the product, we multiply it by x minus 2, and then by 1/2. Okay, so I can write this here. Y equals 1/2 times x minus 2. So since this is a difference of 2, like this one is minus and plus with the same terms, right? And so if we multiply this, it's going to eliminate the middle term, right? So what we need to know is just the product of x times x, which is x squared. And then we multiply the last terms because it's going to eliminate the middle term. So we don't need to multiply the outer and the inner terms, right? So multiply negative 3i and positive 3i. Negative 9i squared.
I know you said we don't need to multiply the middle terms, but why not? Why would we do a -3i times x?
Well, if we multiply the outer and the middle, inner terms, it's going to give you, I'm just going to show, negative 3xi. And then if we multiply this to that, that's going to be positive 3xi. So what happens to these two terms? It's going to cancel out. So we don't need that, right? If we know that it's going to be like plus and minus with the same terms, with the first and second, so it's going to eliminate the middle term, so we don't need to do that. But if you want, that's fine, okay? Yes, but if this is like x plus 3i and x plus 3i, then it will give you a middle term, right? Yes. Say again? Yes. What is I squared again? If I is square root of -1, if I is equal to the square root of -1, if you take the square of I, that means you're going to take the square of the square root of -1. And so what's the value of I squared? -1. Not 1, but -1. Because again, if you square the square root, it's going to cancel out the square root. So what's inside is just -1. Yes?
-9i squared, positive 9.
That's going to be positive 9, correct. So that means if you want to eliminate the I squared, because I squared has the value of -1, and so it's just the same as -9 times -1. That's why Ivy said it can be, yes, positive 9, right? So I can write, I'm just going to show this here. -9 is your -9 here. I squared is -1. The value of I squared is -1. So I just multiply that by -1 to just eliminate the I squared. Because if you write the equation, we have to eliminate the complex roots, right? So I can write this as y equals 1/2 times x minus 2, and then times x squared plus 9. Right? Okay. Any questions so far? Okay. Now we just have to FOIL. We can FOIL these a binomial and this binomial, and once we get the product, we multiply everything by 1/2. Okay? All right, so remember the FOIL, you can do box method. We can multiply x times x squared. But again, I'm just going to copy 1/2. X times x squared is what? X cubed. And then we can multiply x times 9. But then I know that we're going to arrange it anyway to descending orders of the powers, right? Or the exponents. So I can also multiply the -2 and x squared first, because I know next to x cubed is going to be x squared. So -2x squared, and then negative x times 9, positive x times 9, that's 9x. And then -2 times 9 is -18. Question? Question? So again, make sure you know the skill. Make sure you have the skill in multiplying two binomials. Okay, again, if you don't know these, let me know, or you can come after school to ask for help. Okay, the skill, you should know this skill, right? Using the FOIL or distributing or multiplying two binomials. Okay, then the final part is we just have to multiply all of that by 1/2. And it's going to give us the final answer. Yes. So y equals, I can do x cubed divided by 2. Mm-hmm. Minus x squared.
Plus 9x over 2.
Yes.
Minus 9.
Or 9/2 x and then minus 9. Yes.
Mr. Hahn,
Yeah.
we multiply that. Wait a minute.
Yes. But the 2 is in your denominator. That's why the 2 should be under. Yes. All right. So this is now your standard form. Any question? Okay. Yeah.
So if we had another like -9i squared,
Uh-huh.
would we if we had another like a different number, would we still multiply it by -1?
Yes.
Okay.
Yes. So if you have 2 of that, that gives you an I squared. Then every time you have an I squared, again, the value of that is -1. And the goal is to eliminate these i's, because when we write the final equation, it should only be the variable x and the numbers, right? So every time you have that, multiply it by -1, okay? Okay, so any questions for the first example? All right, let's do the second. The second is a quartic polynomial. What is the degree if it's quartic? 4. So this is degree.
X equals square root of 2. X equals
Negative square root of 2 and x. Yes. All right, so those are the roots. So Ivy mentioned all the 4 roots. Again, if you have a square root, it comes with a pair to complete 4, right? All right, so we got x equals -3, x equals square root of 2. This is an irrational, so it comes with a pair. Negative square root of 2. And then the last one is x equals 0. Correct. Okay? Yes?
Like, what does irrational mean?
Irrational. Irrational is if you take the square root of the number, it's going to give you a non-terminating and repeating decimal. So it's not going to stop, right? Like 1.5 is rational because you can express 1.5. When you say rational, if you can express a number as numerator divided by denominator, that's rational, right? So 1.5, I can express that as 3 over 2, okay? But because I can express it as 3 over 2, that is rational. Irrational are those that you cannot express as a fraction. right? Because if you have like 1.23567 through 3567, 23567, you cannot express that as a ratio of A over B, right? You cannot express that as a fraction.
Has no end.
Yes. So it's irrational, yes.
Okay, thank you.
Okay. All right, so once we have these, then we can write the polynomial in the intercept form, okay? Let me just write these as factors. So this is x plus 3. This is x minus square root of 2. This is x plus square root of 2. And again, x equals 0. I can just write that as x. Okay? So now we can write this including the leading coefficient, but the leading coefficient is also 1. I will just put 1 here just to know, just for you to know that that should be the first one that we're going to put in, right? 1 times all of that. It's easier if we can write x plus 3 and x first, and we put these conjugates in the last part, okay? Because it's easier to have them together beside each other because it's easier to multiply these two, right? All right, so that's x times x plus 3, and then x minus square root of 2, and x plus square root of 2. So you should have 4 factors because it's a quartic polynomial. Question? Okay. Now, since we have 4, what we can do is I can multiply the first 2, and then you multiply the last 2, right? So this is just y equals, if I multiply x times x plus 3, you just have to distribute the x to x plus 3. Okay, so that means this is going to be what? X squared plus 3x. I multiply the first 2 terms, right? Okay, and then we're going to multiply the last 2. Now again, this is the form where you have the same first and second, and it's minus and plus, so it's going to eliminate the middle term. Okay, so you just need to multiply x times x and negative square root of 2 and positive square root of 2. Right? What is x times x? X squared. And then what is negative square root of 2 and positive square root times positive square root of 2? That's going to be negative square root of 4. And what is square root of 4 is 2. Right? I'm just going to show that on this side. So you got negative square root of 2 times square root of 2. It's going to give you square root, negative square root of 4. And that's just negative 2. Right? Because square root of 4 is 2. So I can write this as minus 2. Okay? Not minus 4. Because some students will put 4 instead of 2. Okay? So think of that when you multiply 2 irrationals or 2 radicals, right, in math 2, right? When you multiply 2 radicals, you copy the radical symbol and you multiply what's inside, right? 2 times 2 is 4. Square root of 4 is 2. And then copy the negative sign. Okay. Now, once we have this, then we can do the FOIL method, right? So we can multiply, because this is quartic, the highest exponent must be 4. So x squared times x squared, what is that? X to the power of 4. And then I can multiply, because I know I have to arrange. So I can multiply 3x times x squared. What is that? 3x cubed, right? And then multiply x squared times negative 2. What is that? Negative 2x squared. And then the last one, multiply 3x times negative 2, negative 6x. Okay? So this is now, yep, that's your standard form. Any question? Let me know if you were able to get the same answer. If you're working on it and you got a different answer, let me know, okay? All right, so again, the signs are also very important here. Okay, last example. Number 3. Any question again with number 2 before we proceed? All right, let's do number 3. So number 3, we're going to write a cubic polynomial with roots at -1 and 1 minus 3i with a leading coefficient of -2. So again, cubic, we're going to write a polynomial with degree 3. Okay? And then let's write the roots here, or the zeros. Okay? So the first one is x equals -1. The second one is x equals 1 minus 3i. It's a binomial. And again, it comes with a pair. What is the pair of 1 minus 3i? 1 plus 3i. So x equals 1 plus 3i. Make sense? Okay, so we got all these 3 roots. Again, we should only have 3 because that's degree 3. Now, the goal is to write these as factors, right? So write these as factors. So what's the factored form of x equals -1? Simple. That's x plus 1. Well, what about x equals 1 minus 3i? What's the factored form?
X minus 1
Minus
3
okay.
imaginary, and then you would do
Plus.
x
Yeah.
plus.
Okay. So Rowan is saying x minus 1 minus 3i. Right? Because you always do x minus whatever is the number. Right? So if you have that, you can write this as x minus 1 plus 3i. What did I do? I just distributed the negative to this. Okay? Because this is your entire 0. So when you write this as a factor, that's x minus that. But then you have to distribute the negative sign. So that's going to be x minus 1 plus 3i. Okay? Let's do the same thing with this. What is the factored form of this? This is going to be x minus this. Right? What is this? 1 plus 3i. I have to put it inside the parentheses because we're going to subtract this entire thing from x. Make sense? So I can write this as what? How do we write this now? Simplified form. X minus 1 minus 3i. Any questions so far? Again, you just distribute the negative to the binomial because your 0 or roots is a binomial, right? Okay. Now, so we just have to do as, write this as an intercept form. So y equals -2. -2 is your leading coefficient. That's your a. And then just write all the factors. So x plus 1, and then x minus 1 plus 3i, and then x minus 1 minus 3i. Okay, do you understand until this part? Okay, does that make sense? Again, this is your intercept or factored form. Okay, but again, we're asked to write this in the standard form. Okay, so how do we multiply this now? How do we simplify this to come up with the standard form? We can multiply the last 2, yes. Okay, now we can consider this. If you want to do this in this way, you can. Okay, I'm just showing 2 different methods, or giving you the idea on 2 methods that we can do. The first method that we can do, if we multiply this, we can multiply a trinomial times a trinomial. So meaning we're going to multiply the first term to all the terms there, and multiply -1 to all the terms in your second factor, and then multiply the 3i to all the terms. That means you multiply all these three terms by this. Okay, that's one method. Another method is you can use the pattern of a difference of two squares. Right? Because it looks like difference of two squares because you can group x minus 1, that's your first term, and then the 3i, that's going to be your second term. Okay? Let me show you. I can write this as -2 times x plus 1. And then I'm just going to show you that I can write this as x minus 1 plus 3i. So I'm going to treat x minus 1 as my first term because it's exactly the same as x minus 1 in the second factor. And then I can write this as x minus 1 minus 3i. So it looks like if I multiply x minus 1 times x minus 1, it's like taking the square of x minus 1. And then it's going to eliminate the middle term because it's plus and minus. And you got the same terms in your first and second. And so you just have to multiply 3i and -3i. And x minus 1 and x minus 1. Right? That's going to be easier because you just have to multiply the first to the first and the second to the second. If you do the trinomial times trinomial, you're going to multiply all the three terms to all of these. It's going to be a lot of work. Okay? But again, once you see this, you can also do this in this way, right? So I'm going to write this as y equals -2 times x plus 1. And again, I can multiply this times this, right? So it's like x minus 1 times x minus 1. So what is that? That's x squared minus 2x plus 1. Right? If you multiply x minus 1 by itself, it's like x minus 1 to the power of 2. Right? Or it's like x minus 1 times x minus 1. And again, using the FOIL method, it's not going to eliminate the middle term here. So we have a middle term, -1x and -1x. So that's going to be -2x. Right? If you're going to sum up the x's. And then -1 times -1 is +1. And then we can multiply 3i and -3i. What is that? That is, yes, -9i squared. 9. Yes, just 9. Make sense? Okay, so again, so if you have an I squared is -1. So you can write this as -9 times -1. So this is going to be +9. Okay, +9. All right, so this will be y equals -2 times x plus 1. And this is going to be x squared minus 2x plus. Because we know that this is going to be +9. So I'm just adding the 9 to the 1. So this is going to be +10. Question? Because it's like this is connected to this. You're not multiplying the entire 9 to x squared minus 2x plus 1. Whatever's the sign of this, for example, if it's going to be -9, you just have to deal with that with your constant. So 1 minus 9. But then since this is going to be turning to +9, okay, I'm just, so that you will not be confused, I'm just going to erase that. I'm just going to say -9i squared.
So you would just like kind of combine them on.
Yes. So again, this -9i squared is +9. So you can just like write this as x cubed minus 2x plus 1 plus 9. Right? And so, which makes it 10. Okay? All right? Okay. So now that we have this, okay, then we can multiply these two and then multiply by -2. So multiply the second binomial times trinomial. So -2. I can just multiply this to all of that. So x times x squared, that's x cubed. X times -2x, -2x squared. X times 10 is 10x. And then we're going to multiply the 1 to all of these. But it's just going to be the same because you multiply that by 1, right? So 1 times x squared minus 2x plus 10 is going to be x squared minus 2x plus 10. So it's just the same, right? And then just combine like terms and then multiply it by -2. So y equals -2 x cubed. And then you do, what is -2x squared plus x squared? Minus x squared. And then 10x minus 2x plus 8x. Right? And then plus 10. And then we just multiply by 2 and we're done. Okay? So y equals -2x cubed. And then again, you multiply that here, right? So this is plus 2x squared minus 16x minus 20. This is your standard form. Any question?